Hi, so this is our assignment 3 that I'd like to go through you with. Firstly, I'd like to say that we have some settings for Eclipse so you can easily run it on there. We have some tests, just full coverage of our heap adaptable priority queue that we created. What we devised as our real world test scenario in this case is a hospital, for example in A&E, where patients are coming and may seek urgent medical attention. There has to be a sort of a way to decide who's higher and who's lower on that list, who needs medical attention most urgently. So, for example, there might be a member of staff that comes up to you and jots down a couple of your details, your age, your sex, whether or not you're pregnant, whether or not you have cancer, etc., etc. And once they see the state in which you're in, they can add you to the queue, see where you fit in there. So, these details might be taken down on some sort of software similar to that of Google Surveys, where all the patient's data will be exported to a somewhat like Excel spreadsheet, and then a priority queue can be made from that. So, as we just discussed, to get the patient's priority, we take age into account, and we also take their medical conditions into account. So the more medical conditions they may have, the more likely they are to be higher up on this list. So if they answer true to that they have gout, that they have pneumonia, they'd be higher on the list, and we also take age into account as a consideration. So now we go to our main, and we've devised two test scenarios here. The first is using our adaptable priority queue heap, and the second is just taking that array list and sorting it. So that CSV file we have here, what we've done now is get an array list of patients from that sheet, where each row represents a patient object. Now, the reason we went with a heap for this design is that it's quite efficient. If a new patient enters, we can insert a new patient into this priority queue. If a patient leaves, we can remove them, or if a patient needs updating, we can also update their condition. Let's say they developed a new medical condition and their state changed, and then we can adapt their priority in the list. So, for example, I just wanted to print it out here just so you can see. Each patient gets a unique patient ID. Obviously, their age is taken into account and their priority score. These are just three of the patient attributes I wanted to show to you. But, those were just for show. They won't be in the final version. So now if we rerun this without that, we see that our adaptable priority queue is quite a bit faster than just having an array list and sorting it. And one other thing I'd like to mention is we did make it so that those who need more urgent medical attention would be highlighted in red, and those who are not so urgent are in green. Those in the middle are in yellow. Just so that staff can quickly see who needs urgent medical attention if they want to see the whole list. But most of the time they'll just be picking the next in line, which would be the root node, which is very easy to get O of 1. So I didn't think it would be much of a test to add it in because it's already quite efficient. So what we're trying to look at here is registering patients and trying to improve the efficiency of that. And we see that sorting an array list isn't a very ideal solution because every time a new patient enters, you have to resort the whole list. With the heap, you only have to reshape patients who have lower priority from that point on. You don't have to reshape the head of the tree. So if I get an image there of a min heap, so you see, let's say this patient needs to be, a patient is added at this position. Only children nodes would have to be reshaped. The other side of the tree remains unaffected, so that would also increase speed. But as we see here, even all things remaining constant, sorting the array list once is already less efficient than using a min heap to create an adaptable priority queue. And the fact that it's adaptable, as I said, is very important because, you know, patients enter and go all the time. Yeah, and it works out roughly to be twice as fast. And I'm sure as more data is introduced, that trend will only continue to be exacerbated. Yeah, so that's the end of our assignment. Thanks.